Hello, today we are going to solve a very important question in mathematical economics. So we are going to solve a question on cross-partial derivatives. So pick your calculator and let us start, and let it not be as if I'm doing magic. We flow together. So now the question is, suppose a production function is given as Q equals 60k raised to the power of 0.4, L raised to the power of 0.5, and R raised to the power of 0.25. So the question is, derive all the first order and cross-partial derivatives. So now, the production function is Q equals 60k raised to the power of 0.4, L raised to the power of 0.5, R raised to the power of 0.25. So now we are going to find the first order partial derivatives. First order partial derivatives. So now, there are some basic things that you need to understand before you flow well under this topic, because you did differentiation and you have been seeing symbols like this. You have been seeing delta, a symbol of this nature, or a symbol of this nature, and a symbol of this nature. And today we are talking about cross partial, which is like this. So now, this one is a capital letter for delta, and this one is a small letter for delta, and this one is when you take the limit of this delta, then you have this one called D. So this one is the cross partial that we shall be using to solve this question. So now, you also have to recall your basic rule for differentiation, which is when you have y equals x raised to the power of n, the basic rule of differentiation is dy dx, dy with respect to s here generally is n times s raised to the power of n minus 1. So we are going to apply this rule, this general rule of differentiation to solve this question. So now, to derive all the first order partial derivatives, we must start with this one, followed by this one. So now, you have a word here, partial. It means that if you are differentiating this thing with respect to k, you are going to hold L and R constant. That is the essence of this partial here. So now, the partial derivative of Q, this symbol is very important. Partial derivative of Q with respect to k is equal to the power of k here is 0.4. Going by this rule is 0.4 times 60 raised to the power of 0.4 m minus 1 minus 1 l raised to the power of 0.5 r raised to the power of 0.25. You are differentiating with respect to k. So L with its power and R with its power will be hold constant. That is the essence of this partial. So now, the partial derivative of Q with respect to k is equal to 0.4 times 60. Equal calculator. 0.4 times 60. You will have 24. K raised to the power of 0.4 minus 1. You will have minus 0.6. Then, if you are still not clear, you pick your calculator. 0.4 minus 1. Here, you have minus 0.6. Then, L with its constant will be hold constant. R with its constant, R with its power constant. So now, the first order partial derivative of Q with respect to K is this. So now, the partial derivative of Q with respect to L, by the L, is equal to the power of L, which is 0.5 times 60 raised to the power of K, 60K raised to the power of 0.4, L raised to the power of 0.5. Since we are differentiating with respect to with L, we are going to subtract the power of L by 1. Then add to the power of 0.25 with the whole head constant. So now you have the partial derivative of Q with respect to L, which is equal to 0.5 times 60. 0.5 times 60 is 30. 30 curve with raised to the power of 0.4. L 0.5 minus 1 is minus 0.5. R raised to the power of 0.25. So this is the first order partial derivative of Q with respect to L. So now, the partial derivative of Q with respect to R, is equal to the power of R, which is 0.25 times 60K raised to the power of 0.4, L raised to the power of 0.5, R raised to the power of 0.25. Then since we are differentiating with respect to R, we are going to subtract the power of R by 1. So you will have partial derivative of Q with respect to R will be equal to 0.25 times 60. 0.25 times 60. You will have 15. 15K raised to the power of 0.4. F raised to the power of 0.5. R raised to the power of minus 0.75. Because 0.25 minus 1 is minus 0.75. So these are the first order partial derivative of the production function Q with respect to K, M, and R. So now we shall be computing the cross partial derivatives. Cross partial derivative. Cross partial derivatives. Now there is a rule that cross partial derivatives are always equal in pairs. So now the cross partial derivative of K in pair of M must be equal to the cross partial derivative of Q with respect to L with respect to K. They must be equal. Now this is a format of a cross partial derivative. It is cross because if you look at it here very well, you discover that you have a cross partial derivative with respect to K with respect to L. Coming to this side, you have with respect to L before K. Here is K, L, K. So it is believed that when you compute the cross partial derivative of this one, you should get the same figure or the same value as this one. So let's flow. So now, a cross partial derivative of Q is a second derivative. These two here standing for second derivative. With respect to K with respect to L means that you have two of this thing here. That is the essence of this square. So you can write it in this way. D, the cross-partial derivative of K, times the cross-partial derivative of Q with respect to L. You multiply this by this, you have this, and you multiply this and this, you still get the same thing. But the cross-partial derivative of Q with respect to L is equal to, that is this aspect. The cross-partial derivative of Q with respect to L have been computed. And look at the value here. The cross-partial derivative of Q with respect to L. That is the cross-partial derivative of Q with respect to L. Look at it here. So now, in place of this, we put this value. So to compute this, you discover that we have already computed the value for the cross-partial derivative of Q with respect to L. So then, cross-partial derivative of Q with respect to L is equal to Q with respect to L is equal to 30K raised to the power of 0.4, 30K raised to the power of 0.4, L raised to the power of negative 0.5, R raised to the power of 0.25. So now, in place of this cross-partial derivative of Q with respect to L, you impute this value. So you have second order derivative of Q with respect to the cross-partial derivative of K with respect to the cross-partial derivative of L is equal to the cross-partial derivative with respect to K, A to 30 K raised to the power of 0.4, L raised to the power of negative 0.5, R raised to the power of 0.25. So now, we are differentiating with respect to K. So you are going to multiply the power of K by 3. So you will have 4. Since it is with respect to K, is this power of K that we are using. 0.4 times 30 K with respect to 0.4 minus 1. L with respect to negative 0.5, constant. R with respect to 0.25, constant. So now, you will have the cross-partial derivative, that is the second order derivative of Q with respect to K with respect to L will be equal to 0.4 times 30. 0.4 times 30. You will have 12K. Then 0.4 minus 1, you have minus 0.6. Then L raised to the power of minus 0.5. R raised to the power of 0.25. So this is the second order cross-partial derivative of K with respect to L. So we are going to compute the second order cross-partial derivative of Q with respect to L, K, and we are supposed to get the same value. The second order cross-partial derivative of Q with respect to K and L. So the second order cross-partial derivative of Q with respect to L with respect to K. The difference is here, K is before L, and here L is before K. So the value here is supposed to be equal to this one. So this thing can be written as cross-partial derivative with respect to L times cross-partial derivative of q with respect to k. So this value have been computed. So but cross-partial derivative of q with respect to k have been computed. So look at it here. Cross-partial derivative of q with respect to k is what? 24 k raised to the power of minus 0.6 L raised to the power of 0.5 R raised to the power of 0.25. So now, in place of the cross-partial derivative of q with respect to k, you impute this value. You will have the second order cross-partial derivative of L with respect to k, which is equal to cross-partial derivative with respect to L into, in place of this value now, you have 24 k raised to the power of minus 0.6 L raised to the power of 0.5 R raised to the power of 0.25. So now look at what is here. It's with respect to L. So we are going to multiply everything here by the power of L, which is 0.5. So you have the second order cross-partial derivative of q with respect to L with respect to k will be equal to, the power of L here is 0.5. So you have 0.5 times 24 k raised to the power of minus 0.6 L raised to the power of 0.5 minus 1 as a rule of differentiation. Then R raised to the power of 0.25 is constant. Since it is cross-partial, you are going to touch only L. So you will have the second order cross-partial derivative of q with respect to L with respect to k will be equal to 0.5 times 24, that is the half of 24, which is 12k raised to the power of minus 0.6. Then L raised to the power of 0.5 minus 1 is minus 0.5, and R raised to the power of 0.25. So now you will discover that the second order cross-partial derivative of L with respect to k, this thing here is equal to this one. They are equal. You have 12k with respect to minus 0.6 as what is here, and L with respect to minus 0.5, R with, raised to the power of 0.25. Therefore, the cross-partial derivative of q with respect to k with respect to L is equal to second order cross-partial derivative of q with respect to L with respect to k. This thing is true. The cross-partial derivative of q with respect to L with respect to R should be equal to the second order cross-partial derivative of q with respect to R with respect to L. This is why it is called cross-partial, because look at it here, we discover that L is before R, coming to this one, R is before L, so it is cross, like that. So now, for this aspect, the second order cross-partial derivative of q with respect to L with respect to R is equal to the cross-partial derivative with respect to L times the cross-partial derivative of q with respect to R. This is just the same thing with this, because this cross-partial derivative times this one will give you the cross-partial derivative squared, then q. Then with respect to the cross-partial derivative of L times this will still give you this. So it implies that the second order cross-partial derivative of q with respect to L with respect to, it implies that the cross-partial derivative of q with respect to r have been computed. Derivative of q with respect to r have been computed as 15k raised to the power of 0.4 l raised to the power of 0.5 r raised to the power of negative 0.75. So in place of a cross-partial derivative of q with respect to r, you will impute this value. By so doing, you have the second order cross-partial derivative of q with respect to l with respect to r, which is equal to the cross-partial derivative with respect to l into, that is in place of this. This one is repetition. In place of this, now you impute 15k raised to the power of 0.4, l raised to the power of 0.5, r raised to the power of negative 0.75. Close the bracket. So you are differentiating with respect to l. So you are going to multiply everything here by the power of l, which is 0.5. By so doing, you will have 0.5 times, the second order cross-partial derivative of q with respect to l with respect to r will be equal to 0.5 times this, which is 15k raised to the power of 0.4 l raised to the power of 0.5. Since we are differentiating with respect to l, you minus the power by 1. So you will have r with respect to negative 0.75. So now, 0.5 times 15, you will have second order cross-partial derivative of q with respect to l with respect to r will be equal to 0.5 times 15, that is a half of 15, which is 7.5. 7.5 k with respect to 0.4, l with respect to 0.5 minus 1 is minus 0.5, then r raised to the power of negative 0.75. So this part is for this one. So we are succeeding in getting the left hand side, which is the second order cross-partial derivative of q with respect to l and r. So it is believed that what is on the left hand side must be equal to what is on the right hand side. So we are going to compute this side. So now we have the second order cross-partial derivative of q with respect to r with respect to l, which is the same as the cross-partial derivative with respect to r times the cross-partial derivative of q with respect to l. But the cross-partial derivative of q with respect to l have been computed. The cross-partial derivative of q with respect to l is this. So you will have 30k raised to the power of 0.4, l raised to the power of minus 0.5, r raised to the power of 0.25. So now, the second order cross-partial derivative of q with respect to r with respect to l is equal to the cross-partial derivative with respect to r. Each, that is, this one is repetition. Cross-partial derivative with respect to r. Look at it here. So in place of this, you will impute this value. You have 30k raised to the power of 0.4, l raised to the power of negative 0.5, r raised to the power of 0.25. So now, if you look at this, we are differentiating with respect to r. So we are going to take the power of r, which is 0.25, and multiply by everything here. You will have the second order cross-partial derivative of q with respect to r with respect to L will be equal to power of r is 0.25 times 30k raised to the power of 0.4 L raised to the power of negative 0.5 r, which we are differentiating with respect to raised to the power of 0.25 minus 1. So now you have the cross-partial derivative of q with respect to r with respect to L will be equal to 0.25 times 30, 0.25 times 30, you will have 7.5 k raised to the power of 0.4 L raised to the power of negative 0.5 r. 0.25 minus 1 is negative 0.75. So you agree with me that this is equal to this. What you have here, 7.5k L raised to the power of 0.5 r raised to the power of negative 0.75. So it is confirmed that the cross-partial derivative of q with respect to L with respect to r is equal to the cross-partial derivative of q with respect to r with respect to L. Oops. We are going to take the cross-partial derivative of q with respect to k, with respect to k, with respect to r. It will be equal to the cross-partial derivative of q with respect to r with respect to k, because we did kl, lr. So the last pair is kr and rk, which is kr, rk. So it is believed that the left-hand side must be equal to the right-hand side. So let us prove that. So the cross-partial derivative of q with respect to k with respect to r is the same as cross-partial derivative with respect to k. That is the cross-partial derivative of q with respect to r. You discover that the cross-partial derivative of q with respect to r has been computed. Cross-partial derivative of q with respect to r, which is 15k, but the cross-partial derivative of q with respect to r is equal to 15k raised to the power of 0.4 L raised to the power of 0.5 and r raised to the power of negative 0.75. So now the cross-partial derivative of q with respect to k with respect to r is equal to the cross-partial derivative with respect to k. Then in place of this, q with respect to r, you impute this value, which is 15k raised to the power of 4 L raised to the power of 0.5, r raised to the power of negative 0.75. So now, look at this. We are differentiating with respect to k. It therefore means that we are going to multiply everything here by the power of k, which is 0.4. So you will have the cross-partial derivative of q with respect to k with respect to r, which is equal to, with respect to k, so the power is 0.4. 0.4 times 15, k raised to the power of 0.4. Since we use this power, we will subtract this power by 1. L raised to the power of 0.5, r raised to the power of negative 0.75. So now, we have the cross-partial derivative of q with respect to k with respect to r, which is equal to 0.4 times 15, 0.4 times 15, you will have 6. 0.4 times 15, you will have 6, k raised to the power of 0.4 minus 1, which is negative 0.6. Then L raised to the power of 0.5, add raised to the power of negative 0.75. So now we are going. So we have succeeded in getting the left-hand side. So cross-partial derivative believes that the left-hand side must be equal to the right-hand side. So to get the right-hand side, we have the second order cross-partial derivative of q with respect to r with respect to k, which is the same as the cross-partial derivative with respect to r, this one, times the cross-partial derivative of q with respect to k, this one. So bet the cross-partial derivative of q with respect to with k has been computed. Cross-partial derivative of q with respect to k is this, which is 24k raised to the power of negative 0.6 l raised to the power of 0.5 and r raised to the power of 0.25. So now, second order cross-partial derivative of q with respect to r with respect to k will be equal to cross-partial derivative with respect to r, what is here. Then in place of this, you will impute this value because it has been computed, which is 24k raised to the power of negative 0.6 l raised to the power of 0.5 r raised to the power of 0.25. So now we are differentiating with respect to r. So we are going to multiply everything here by the power of r, which is 0.25. By so doing, you will have the second order cross-partial derivative with respect to r with respect to k, which is equal to 0.25 times 24k with respect, raised to the power of 0.6 l raised to the power of 0.5 r raised to the power of 0.25. But since we are using the power of r, I will subtract this thing by 1. So you will have the cross-partial derivative of q with respect to r with respect to k as 0.25 times 24. You will have 6k raised to the power of negative 0.6 l raised to the power of 0.5 r raised to the power of 0.25 minus 1 is negative 0.75. So you will agree with me that this is equal to this. So it has been proven that cross-partial derivatives are equal. It therefore means that the cross-partial derivative of q with respect to k with respect to r is equal to the cross-partial derivative of q with respect to r with respect to k has been proven. Thank you so much for watching this video. If you still have any question concerning this topic, drop it in the comment section.